Welcome to our virtual storm spotter class. Happy to have you here this evening. This is just going to be an hour from 7 to 8 p.m. Wanted to start out with a couple of QR codes, one for the storm spotter reference guide and one for the Comet Skywarn spotter training. So, and then we, of course, on the right side, we have all of our social medias and our website and our phone number in case you ever need us. So we'll go ahead and get started. My name is Angelica Soria. I'm a meteorologist here at the National Weather Service in Springfield, Missouri. So happy to be here today and happy to have you guys all here. So we'll get started. So just one quick thing going through this GoToWebinar interface. Post questions in the question section of the GoToWebinar. All attendees will be muted through the webinar to prevent background noise. So we're going to go into what this course is not. So we are not going to encourage any, chasing or encourage any dangerous activity of getting close to a tornado or anything like that. This is just simply to inform you of what to look for, when to look for it, and what to report, and a few of the things we do here at the office, just some few meteorology things that we are able to teach you this evening. But again, just want to remind people to be safe with the information that we do teach you all today. So again, no chasing. This is not Twister. Just be safe when you're outside, especially during severe weather season. We just want to make sure you guys are all keeping yourself safe. So this is the agenda, all the topics we're going to go over. We're going to start out about the Weather Service. We're going to look at the Spring 2024 outlook. We're going to go through forecasting severe weather, and then look through NWS severe weather products. And then we're going to go through identifying storm types and features, and then sending storm reports, and then severe weather safety and preparedness. So we have a poll, and I'm going to send this out. Let's launch it. So how many tornadoes occurred in the Springfield County warning area in 2023? Gonna give you guys about a minute to respond and see who can get it right. So far it looks like we've got B winning. So I'll wait about 30 more seconds and see if we can get more votes in. Okay, so it looks like B is the highest answer right now, with C coming in close second. So go ahead and close the poll now. Okay, so let's see what the answer is. B. So a lot of you got, 58% of you guys got it right, and then 29% of y'all got 10, which isn't far off. So good job. That was good. So that was just a quick little poll that we started out with, but now we're going to move into about the National Weather Service. So our mission: provide weather, water, and climate data, forecast, warnings, and impact-based decision support services for the protection of life and property and enhancement of the national economy. And our vision is a weather-ready nation. So that means that society is prepared for in response to weather, water, and climate-dependent events. That's just something we try to incorporate every single day here. So these are the two things that that drives our mission every day. It's really important to us. So next up is building a weather-ready nation. So we have 122 forecast offices all around the United States, and the outside of the continental United States, we have them in Hawaii, Guam, Puerto Rico, and Alaska as well. So next up is our county warning area. I believe it's 35 Missouri counties and 3 Kansas counties, if I'm correct. or is it 30? It's 35 or 36. But we do most of south central Missouri, and then we do have those 3 southeastern Kansas counties over there, the Bourbon, Crawford, and Cherokee counties as well. So these are the counties we serve, and there are other forecast offices that take care of the rest of Missouri to our north and to our northeast as well. So spring 2024 outlook, let's talk about it. Just a brief overview. April through June 2024, the seasonal temperature outlook is looking warmer than normal, looking at the graphic on the left in those orangish colors. So expect it to be warm. And then looking on the right, our seasonal precipitation outlook, April, May, June, we are looking at above normal as well. So just warm and rainy, that's what we're expecting, which we've kind of already seen these past few weeks, and it's going to get pretty warm this weekend into the 80s, I believe. So this is looking to be quite true already. So next we'll move over to chances of El Nino, La Nina, and neutral. These climatological patterns really do affect what kind of spring we'll see, like what I just showed, whether it's going to be a wetter than average or a drier than average or warmer or colder. But it looks like we're going to be in the neutral zone. So it looks like it's going to be around 80% chance for a neutral in April, May, and June. So this in the past has led to a bit more of an active severe weather season. So we'll just have to keep going through April, May, June and see what Mother Nature gives us. But so far it's been pretty active around here. So with that, we're going to move on to forecasting severe weather. So this is just what a typical setup would look like over the United States, the Central Plains. For our area in Missouri, we'd have a low pressure system coming through, and then we have a lot of moisture coming up from the Gulf of Mexico, which coincides and then can give us heavy rain, severe weather outbreaks, things like that. So this is just a typical setup, but not every setup will look like this. So assessing the atmosphere for thunderstorm ingredients. Well, first we need moisture, then we need instability, then we would need a lifting mechanism, and then we need wind shear. So you need all of these components to have thunderstorms. And if you're missing one or one is more than the other, it can really affect what the storm mode is and how they develop. And they may look really good in southwest Missouri, but as they push further east to the St. Louis area, they could fall apart. It's because one of these things is maybe more than the other, so they all have to be in a perfect balance in order to get thunderstorms. So assessing moisture. So we first look at, is there moisture available in the atmosphere to support thunderstorms? So for our area, we like to look at surface dew points and see if they're greater than 55 degrees Fahrenheit. It's different all around the country depending where you are, but we like to use 55 as one of those threshold values that we look for. So next, we use what's called CAPE, and that's convective available potential energy. And this helps us assess the instability. If you've read any of our forecast discussions, you see that we throw around the acronym CAPE all the time. And all this does is just, like I said, assess the instability. So how unstable are we? If we're not if we're pretty stable, it's going to be hard for us to get thunderstorms to happen. So we have to look at like the chart on the right that shows the convective potential. So if it's 0, we're stable, which means we probably won't have much that happens. But 0 to 1,000 is marginally unstable, 1,000 to 2,500, and this is, so CAPE is measured in joules per kilogram, so that would be the unit on the CAPE values. So we get up to 2,500, that's moderately unstable. 2,500 to 3,500 is very unstable, and then 3,500 plus is extremely unstable. And we do use models to kind of get these values, but one thing that really helps us look at these values right over us is our weather balloons. So those are really useful in assessing the CAPE right above us in the atmosphere. So after CAPE, we need a source of lift. So you can have all the KP1. You could have 3,500 plus, but if you don't have a lifting mechanism to get that going, it's not going to do much. So we need a source of lift. So that may come in differential heating, fronts, dryline, outflow boundaries, or even different terrains can set that off and then get the atmosphere going, and then you have thunderstorms. Wind shear is another component we need, and this is just the rate at which wind velocity changes through the vertical atmosphere. So speed or directional shear, or a combination of the two, but shear supports organized thunderstorm development. So if you look at the picture, you want more of like the cloud on the left as opposed to the cloud on the right. Sometimes when the shear is pretty strong up in the upper atmosphere, it will tilt the updraft like the cloud on the right, and then your thunderstorms will kind of fall apart. So they're not able to sustain themselves. So then the rain falls ahead of the updraft, and so it could definitely ruin those thunderstorms. But so most of the time we want like what we see on the left, it to be straight up. So the shear has to be perfectly balanced in all up and down the atmosphere in order to keep those thunderstorms going. Because like I said, you could have a really good area of shear over in Joplin, but then you get to Springfield and the shear is too much at a certain part of the atmosphere. They're just going to blow over and they will fall apart. So next up is assessing the weather models. So we look at over 100 models, and they spit out various model solutions. Each model varies on output and input, and we assess the models in based on the model agreement and consistency, which may make a bit more sense on the next slide. So here's just an example of what we call an ensemble postage stamp. So what all it is showing is all these little squares show different model outputs, and so this is how we assess it, and we look to see what's consistent, what's different, do they agree on something, do they disagree on something, and so we use our best judgment in trying to identify, okay, which one is the more correct solution and which one is really just out to lunch. So we have to discern that, and when the models don't agree at all is when we start using a probabilistic versus deterministic forecasting approach, which you all have probably seen if you've looked at our social media posts or looked at our area forecast discussions. It's part of our forecast funnel, which is when it's the event is further out and there's higher uncertainty. We like to use probabilistic terms. As an example, saying like for the Springfield area, there's a 40% chance that you could see 2 inches of rain or more, instead of saying you're going to see 1 to 2 inches of rain on Tuesday. So we use probabilistic far out just to kind of give you guys a taste of what our confidence is as well. If I say, yeah, there's only going to be a 20% chance that you see 2 inches of rain or more on Tuesday for Springfield, the confidence is low that we'll see 2 inches. It'll probably be below that. So we have to, take what the models give us and kind of interpret it in a way that makes sense for us and then makes sense for the public as well. So that's why we use the probabilistic approach when it's pretty far out or when there's still a lot of uncertainty, just to kind of give you guys some context as to what we're seeing and what we're thinking. But then as the event gets closer, we'll use deterministic, like I mentioned earlier, that approach of like, okay, Springfield area is going to get 1 to 2 inches of rain. So that's kind of some insight as to why we do that. And it enhances our messaging in forecasting the potential for severe weather. So we do our best, and weather can be tricky for sure. So we're going to move on to the NWS severe weather products. So we're going to talk about outlooks to watches to warnings. So the Storm Prediction Center outlooks. I assume most people have seen these, but do we know what they mean? So in our graphics, we have tried to start to incorporate, if it's a slight risk day, we'll put 2 out of 5 because the scale goes 1 through 5. And if it's a slight, it's level 2 out of 5. And that just means scattered severe storms are possible. So obviously the further to the right you go, the worse those thunderstorms probably are going to be, or there's at least a risk for that. So this is what each of those categories actually mean, and this is on the Storm Prediction Center website as well if you were interested in having it, or using it as a reminder, you can bookmark it, it's on there. So this is what a typical SPC outlook would look like. Probably a slight and then maybe a contour of a marginal on the outside. So this is a thunderstorm outlook, several days in advance, heads up, time to prepare. We work with the Storm Prediction Center to collaborate and put these out for you all as soon as we can, as soon as we get an inkling of, hey, something may happen here for the next few days. We'll all collaborate and get these made for you guys. Let's see, next up is a watch. So a watch is usually only issued 2 to 6 hours in advance, and this means monitor the weather closely. We've all probably been in a watch, whether that was from last week or the week before, but yes, so this is what a watch typically means, and this is when we usually issue it out as 2 to 6 hours in advance. And then, of course, a warning is the smaller polygons that we issue here, and these are usually 10 to 60 minutes in advance, and this would be your cue to take action and take shelter if you're in one of these. We're going to move on to watches and warnings. So watch is be prepared. Warning is take action. So let's talk about what a watch is. It means that conditions are favorable. It means you need to have a way to receive weather warnings, check the forecast for updates, have a shelter plan, and weather ready. For a warning, that just means potential danger imminent. You guys to take shelter immediately, and if you're driving, find the nearest shelter, make sure to press up and remain ready if you're in a warning. So we also wanted to share some of our criteria for severe weather warnings because we get a lot of questions about what's the difference between severe thunderstorm warning and all the other things we issue. So we've picked just a couple that I'm going to go through with you guys. So severe thunderstorm warning, the criteria has to be winds greater than or equal to 58 miles per hour. Hail has to be greater than or equal to 1 inch in diameter. And we have our severe impact-based warning tags where we could add on to the severe thunderstorm warning. We have a base, which is just what we normally go with. But if it's considerable or destructive, like the winds are 70 to 80 mile per hour, we may have to upgrade it to considerable or destructive because obviously those winds are way worse than 58 miles per hour, which would be a base. So we do have those little identifiers on there that will be in the text of the warning as well when it gets sent out. So look for those too, because that could mean like, okay, these winds are pretty strong. It's a considerable or it's a destructive. We really need to get inside, which you should with the severe thunderstorm warning anyway, but still. So tornado warnings. That just means tornado is happening or it's imminent. It's either radar detected, radar confirmed, or it's reported on the ground. But our tornado impact-based warning tags are based considerable and catastrophic. So we don't, we try to reserve considerable and catastrophic for those really big events. So we don't use those super often, but if the tornado calls for it, we definitely will. But those tags are very serious and could be pretty bad. So we try not to use those too often, and we do keep most of them at a base. But if we see a reason to upgrade it, we definitely will, and those will be on the warning text that comes through of your tornado warning. It'll say considerable or catastrophic on it, or a base if it's just a normal one. So one of the last ones we'll go over is flash flood warning. So this means intense flooding of counties, communities, streams, or urban areas with high peak rate of flow. Flash floods may result from such things as torrential downpours, dam breaks, or ice jam breaks. So we have a lot of low water crossings around our areas, so it's just good to make sure if you see a flash flood warning in your area, turn around, don't drown, don't try to go through there, just be safe and take heed of the flash flood warnings because we do have a lot of low water crossings, so we just want to make sure people are safe because a lot of people do lose their lives in the low water crossing. So we take the flash flood warnings very seriously, and we try to be on top of that and make sure everybody's safe and get those out if we need to, especially over those areas that have low water crossings, for example. So we'll move on to how do we issue the warnings. So on the right is it's a little bit older picture, but we use a program called WarnGen, and we draw polygons based on various factors such as storm speed, movement, development. And the warnings are disseminated through various sources such as broadcast media, weather radio, um, your phones now, I guess. So on the right, like I said, it looks very similar to this, but it's a little dated now. But the GUI on the left is the warn gen, and what we do, steps to issue a warning, is we choose the warning type, we choose the storm type, whether it's one storm or it's a line of storms, and we track and draw the warning box. Then we have to set a length of time for the warning to expire and select the basis for issuing the warning, whether that be it was confirmed or like confirmed on the ground or is confirmed on radar. So we have to put that in there, and then we select specific hazards, expected and appropriate action statements. So we put 1 inch hail or 60-mile-per-hour winds. So we have to go through all that and make sure we're clicking the right things, because sometimes it's bigger than 1 inch hail, so we have to put 1.5 inch and then 70-mile-per-hour winds. So you have to go through and assess, and each storm is different. So and then we do the call to actions as well, which is just like take shelter immediately or go inside, or if you're on the water, which we sometimes issue warnings for the lakes, go inside, seek shelter. So and then we create the text, we read over it, and then issue out the warning. So that's why it takes a second to go through all that and make sure we've got it all good to go. And drawing the polygon honestly can be the some of the most challenging parts of this, because you want to make sure, especially in a tornado warning, for example, you don't want to warn counties that don't need to be in it. So you really have to make sure you draw it correctly, and then you send it out. Like, you want to balance doing it efficiently, but also making sure you got everybody who needs to be in it, and make sure everybody's safe, as well as assessing storm motion. Like I had said, the storms can change. They could speed up, they could slow down, they can dissipate. So you have to reassess storm motion and then draw a new polygon if it moves out and things like that. So sometimes we even split up into 2 radar teams, and we have people take maybe north of I-44 and south of I-44 or something, just to kind of help out, because man, once you have all those polygons going, it could be a lot to manage. So we do our best, and this is just a little insight into how WarnGen works and all the things we have to go through and what we choose to issue on. So next is going to be identifying storm types and features. So this is just a little graphic that shows how our radar works. So our radar sends out an outbound pulse of energy to a thunderstorm, and then the energy is reflected back to the radar from the thunderstorm, and then we end up seeing radar on our computers. So that's just a really quick example, a really quick rundown of how it works. And we also use satellite imagery to look at incoming storm systems. You could tell a lot with that. I could go on and on about satellite, but we do use it for various things, whether it's to see cloud top temperatures or to see lightning, things like that. So it's very, very useful. So let's move on to storm types and features, like the actual storm types. So there's single cell and pulse, multi-cell, squall line, and a supercell. So I'm sure all of you all have seen one or all of these before, but we'll start with the pulse single cells. So these guys look pretty small, but their hazards are hail, gusty winds, lightning, and heavy downpours. So it may only last for a minute or two, but it could drop a lot of rain in that amount of time. So we see pulse thunderstorms probably later on in the summer. We could get them anytime, but we typically see them later on. But yeah, these will hit you pretty quick and then show you out of your area. And multi-cells, those will be a bit more scattered as opposed to isolated. And so these can also produce hail, gusty winds, lightning, heavy downpours, and even flash flooding. Squall lines, we see a lot of these here. And these can produce small hail, straight line winds, lightning, shorter lived, generally rain-wrapped tornadoes, and heavy downpours and flash flooding. These are commonly associated with bow echoes. So we get these often, or it seems like often recently, and yeah, so gusty straight line winds are definitely associated with these and some of the biggest hazards with this one. So this is just a schematic of a thunderstorm. A top view is light rain, moderate rain, heavy rain as you get closer to the outflow boundary gust front, and warm air rises, cold air sinks, and so you can see on the right side, that would be where the shelf cloud is, where that little box that says shelf cloud is. It would be usually out in front of the gust front, and then there's the gust front right there where the arrow is pointing. And you can see these on radar sometimes too. They look like little lines extending from the storm. And this will be like you get like a rush of cooler air right before a storm hits, probably gust front coming through. So that is definitely something that people will always mention. I've felt it before too. It's like, oh, there's the gust front coming out. So yeah, so that is something you could definitely feel occasionally if it pushes out ahead of the thunderstorm. So moving on to reflectivity and velocity. So with this squall line pictured here, it's moving west to east. So you can see the reflectivity along the white line. And then you can also see on the right side, the velocity, the brighter green velocity pixels. And this really just demonstrates high winds. So you can see like the brighter colors represent stronger winds. So you can see how strong those winds are coming with this bow echo in the squall line. So this is typically what we look for in squall lines is if the velocities get brighter, okay, the winds are getting pretty strong. And of course you can sample it as well, but just merely looking at it without any numbers, you can tell that there's strong winds behind this. So the brighter reflectivity is stronger the winds are. So we'll move on to supercells, which are pretty iconic. Most people have seen these and can, see them on a radar and on a map. So hazards are large hail, straight line winds, lightning, long track tornadoes, heavy downpours, and flash flooding. So this is just a quick look at a supercell viewed from the southeast looking northwest. If you're doing this properly, the rain/downdraft is going to be to your right and updraft is going to be to your left. And this position keeps you safe as the storm moves perpendicular to your field of vision. So moving over to the right side, there's a lot of things going on in a supercell, well, in all these storms, but in a supercell, it's easier to kind of just look at one cell. You may see an overshooting top. That's why you can see, sometimes I've seen storms happening in Kansas City. I can see them all the way down here because they have overshooting tops. So you can see that from miles and miles away. And or an anvil. I guess typically you'd see, I guess you could see both. Maybe overshooting top would be more of a satellite thing, but anvil. Either way, these are both indicators that this is a pretty strong thunderstorm that's happening, whether it's over you or it's over somewhere else. And then within that, you have an updraft and then obviously a downdraft on the other side. And then you have a mesocyclone going in the middle, which you'll be able to see on the next slide a little bit better. And then you have a flanking line on the left side of the picture, and then even below that you'll have a wall cloud / tornado, and then maybe even a shelf cloud as well. And we'll go over those clouds a little bit later too, and so we can really talk about what they actually look like in real life and not just in a picture. And so you guys can spot the difference between all of them, because sometimes they can be confusing because the cloud looks kind of scary and you're like, okay, so what is that? So we'll go over that a little bit later and have some real life pictures in there. So yep, here is a radar imagery of a supercell on the left side, and here is a real picture of what one would look like from the highway or a field. Yeah, they look pretty scary. So I'm sure we've all seen them. But they can cause a lot of damage as well. So left side is reflectivity, which you just kind of saw, and then on the right side we'll have velocity. And so on the radar, the red colors are going away from the radar, the green are going towards. And so when you look for a tight velocity couplet, which is what people probably tend to say, like, oh, there could be a tornado there. There could be. if that's the case, look for those really tight couplets there that are in association with the kind of hooking feature that you see on the left and the reflectivity. So if those are coinciding and it's a pretty tight circulation or rotation, we might have to go ahead and issue out a tornado warning. Or sometimes we'll do a severe thunderstorm warning with a tornado possible tag on there too. So just be on the lookout for that, because we do that sometimes too. But so if the circulation was tight enough and it was consistent enough between different radar tilts, because we also assess the storm, in different ways. So if we feel it looks good, and then yes, we'll issue a tornado warning on it. But if the couplet is only at one level and not at other tilts of the radar, then okay, we have to assess what that means. So it could look like this. This could be a tornado for sure, but yeah, so it would look something similar to this. And these couplets are pretty obvious, as opposed to in a squall line, those things where they could do brief tornadoes. Those are a bit harder to spot. So in a supercell, they're a little bit easier to spot, and like I said earlier, they could produce long-lived tornadoes. So those would be bigger and last longer than typically a squall line would. So here are the clouds that I mentioned, storm features. So left to right, shelf cloud, wall cloud, funnel cloud, and we'll go through these individually. So I'm gonna play this video. It's not very long. It's like just a few seconds long. So this is what a shelf cloud would typically look like going through St. Louis. You can see the arch. So this just means the lowering, I'll play it again. Lowering on the leading edge of rain-cooled air, downdraft, and typically expands across much of the horizon, not typically associated with tornadoes. These are typically associated with gusty winds, though. So that is something important to know. It does look a little intimidating, but they're not usually associated with tornadoes. So here's a schematic look at it. Storm movement is left to right. The shelf cloud slopes down and moves away from the rain. So the rain kind of gets pushed underneath the cloud, and then the warm, moist air again rises above it. So this is typically what you would see looking at a shelf cloud. So let's talk about wall clouds. So I'll go ahead and play the video. So this is a wall cloud, and it's an isolated lowering. It's a large area of upward motion, so updraft. It's persistent and important. If it's like this video, if it's rotating counterclockwise, let us know. Call us. Take a picture. Take a video. But the movement does not equal rotation. Having a wall cloud does not mean that a tornado will form, but it's definitely important for us to know. So definitely, if you see something like that, report it to us and we can assess from there. But yeah, those are pretty, I can understand playing it again, what that could look like, So yeah, definitely let us know, because we really value that ground truth, which I'll go over later in the presentation, as well as reports and stuff like that, what to report, how to report it. But if you see something like this, yes, definitely call us, and pictures and videos are always helpful. And here's a couple other pictures of them, just kind of how they could look. But we'll move on to funnel clouds now. I'll play this video. So it's a rotating funnel-shaped cloud extending downward, but not in contact with ground from a thunderstorm or towering cumulus. Rotation at the base of the thunderstorm cloud, updraft. It's an area of upward motion. If it's persistent and it's rotating in smooth appearance, pennant shaped, again, call us and let us know. But this is just kind of how it could look like. But as you can see, it's not touching the ground, but it is a funnel cloud, and it looks like it could, or it looks like it may, but at least in this video, what we see here, it's not reaching the ground. So, oh, there we go. So you could always call us and let us know about these as well. So we appreciate all the reports and anything you all see. So, but yeah, that is that one. And then here's a couple of other pictures of a funnel cloud that can, you know, they come in all shapes and sizes. So there's these two pictures as well. Okay, everybody's favorite, a tornado. So a tornado is a violently rotating column of air extending from a thunderstorm to the ground. Precursors to a tornado is rotating wall cloud and a funnel cloud. They must be attached to the cloud base. It has to be in contact with the ground, debris lofted, and cloud movement does not mean rotation. So, you know, these are a bit, I mean, it can be kind of tricky to, well, you either see it or you don't. So sometimes it's really obvious that it's a tornado, and sometimes you're like, I'm not sure what that is. So I'm hoping this course kind of helps you out with that, and we'll go to the next slide of, I mean, these bigger tornadoes are a bit more obvious, but the smaller ones that go up and come down, I definitely understand why it would be tricky to know what is what. But these are pretty obvious pictures of tornadoes. So I think let's see if I have a poll for this one. Oh, no. No, I think this is just, you could put it in the message bar, because I don't think I have a poll for this one, if it's a tornado or not. So we'll play the clip on the left. And I mean, it's playing, it's just not doing much. So there's the clip on the left, and then we'll play the clip on the right. So the titles of these little YouTube videos kind of gives it away. As you can see in both of these titles, neither of these are tornadoes, but they look like tornadoes, right? So, I mean, it can be difficult, especially if you're not super close to it. But on the left side, it's just rain coming down that looks like a tornado, but it's just a rain shaft. And then on the right side is what we call scud, and scud is just clouds. But they can look like torn up cotton balls, and if they're positioned in the correct way, like this video on the right side, it can look like something weird or even a tornado. So yeah, this one on the right side, when I watched it, I was like, what is that? But and I knew it wasn't a tornado, but it looks weird. But it's scud. They're just clouds. So I guess trick question, neither of them were. But yeah, so you can see that in the YouTube slides or in the YouTube titles. But yeah, so neither of these are tornadoes. Just to make that clear, one of them is rain and one of them is just clouds. So spotter positioning, we do need to go over this. So make sure you have situational awareness, location of a storm, location of spotter, movement and propagation of the storm. Looking perpendicular to the storm motion offers views of up and down drafts while keeping spotters safe. Which spotter is in the correct position to spot a potential tornado on the supercell? Now this one I have a poll for. So I'm going to launch this one, and I'll give you guys about like 30-45 seconds. You guys are pretty quick last time, so I won't keep it out as long. Okay, number 2 is winning so far, but there's some votes for number 3 as well. Oh, nope. Still number 2. Oh, number 3 is coming up a little bit. There's a couple who voted for number 1 as well. I'll just wait a few more seconds and then I'll close it. Okay, looks like most votes are in, so I'll go ahead and close it. And answer is 2. Good job. 64% of you guys got that right. 34%, not a bad answer, but you could get hailed on that number 3 spot. So, and definitely it'd be closer to if there was rotation in that hook area. You definitely don't want to be outside looking at it. You want to be in your shelter. I mean, I know it's to your east, but you never know. So you never know. Supercells can do weird things. So yeah, no, number 3 definitely is not a bad guess, but it's probably not safe to be that close to the storm and outside, no matter if it's to your east and it's already past you, because there still could be lightning as well. So, but number 2 is not bad. Again, we want you guys to be safe with all this stuff: lightning, hail, gusty winds. So just be careful, no matter if you're 1, 2, or 3. If you're in 1, you're probably getting rained on. So sad. You probably won't see much, but just no matter if you're 1, 2, or 3, just remember to be safe. But 2 is the best answer. So sending storm reports. I kind of touched on this a little bit earlier. These are very, very important for us. Reports can save lives. I know this is a very, very old picture of an iPhone on the right, but reports that come in as the storm is in progress are much more valuable than reports that come in hours after the storm is done. We relay this information through warnings, and it can help. I mean, it can trigger or keep warnings active, and the media meteorologists, the broadcast meteorologists, really appreciate these reports, and so you can send it to them as well, and we'll get them, and or they'll see that we got a report, and they'll say, hey, can we put this on TV? Like, yeah, usually they can, but as I talked about earlier in Warrington, when we go through and put like 1-inch hail or 2-inch hail or 70 to 80 mile per hour winds, like how we pick those criteria. Yes, it's from radar, a little bit, but I forget what your reports. Oh, we will change it to like law enforcement reported or the public reported, like golf ball size hail. Then we will change the warning because we're getting ground truth that it's happening, and so we need to update our warning to it's not just radar confirmed anymore. It's happening, and not only does that help us, it helps people downstream of these storms in saying that like no, if Greene County is getting golf ball sized hail, Webster County is most likely going to get golf ball sized hail. So those people outside need to go inside and take shelter or put their cars away, or if there's outside sporting events going on, get those people inside. So that's what we mean by reports can save lives. Is it doesn't just happen for the people currently, like where the storm is over. It helps others downstream kind of know what's happening. And also when the public sees that it's happening to their neighbors, they're more inclined to act on our warnings and things like that. So you never know whose life you can save by, reporting what's happening at your home. So what to report to us? So hail, diameter of the largest stones. So looking for reports of near severe limits. So like I mentioned earlier, that criteria of 1 inch or greater. So pea-sized hail is good to know, but I mean, we want to know, like, is it 1 inch? Is it bigger than that? So that's really important for us. Damaging winds, it's measured speed and or damage. So include tree or limb diameter, tree health uprooted, or is it snapped? So if you've got any tree damage, we would appreciate knowing that. Tornadoes, the tornado, funnel clouds, rotating wall cloud, any damage that happened. You kind of went over that a couple slides ago. And flooding, washed out or flooded roads, and then if you all have any rain measurements, since I know a lot of you guys have gauges, which is super helpful for us. We really appreciate that. So reporting hail. Measure the diameter of the largest hailstones using a ruler or compared to other objects like coins. Anything the size of a quarter, 1 inch or larger is considered severe, like what we talked about earlier. So like I mentioned again, looking for reports of near severe limits, 1 inch or greater. So we appreciate all the pictures and videos, especially now that we have social media. It's very, very helpful when you guys send that in and can compare it to something like coins, or you can measure it. Reporting damaging winds, tree branches, limbs, or complete trees uprooted. What size? How healthy was the tree in the first place? Measured wind speeds, 58 miles per hour or greater. So all these pictures that you see as examples are great to send in to us, and we really appreciate it because it helps us know what you guys experienced there. In reporting tornado / possible tornado, is there rotation? Is there a wall cloud and or funnel cloud? Is there debris being kicked up in contact with the ground? So we kind of talked about what all these pictures mean below on this slide, and how, the first two are great to know, but they're not tornadoes, and the one on the right, the far right, is. So again, we still want to know if you're seeing a funnel cloud or it's a rotating wall cloud, but obviously tornado on the right. So just keep it in mind. Reporting flash flooding. Flooded, closed, washed out roads, let us know, and rainfall measurements help us calibrate our radar. So that is also important, is that we have radar estimated rainfall, just like radar estimates a lot of other things. It estimates rainfall. So it could say that over Springfield, the radar is estimating that we got 2 inches of rain. But if most of the city is saying, no, we got 3 to 3.5 inches of rain, then we know the radar is underdoing it, and we will go and assess from there, and we will change either some of the products we use to make the warnings, or we will keep it in mind while we're issuing out warnings, saying, and we'll adjust it in there, because sometimes in the flash flood warnings it'll say 3 to 4 inches is already falling. An extra 1 to 2 inches will continue for the rest of this evening. So we will change the wording in that as well, which a lot of people use to make decisions. And so it's just really important to get your guys' reports. So reporting basics. So this is things we need to know if you are going to report to us. Who are you? Public, law enforcement, emergency management? What exactly occurred? When was it? And where was it? So use proper terms if you can. Wall cloud, funnel cloud. And please do not exaggerate, because lives are at risk. I took a lot of time to explain how we go through and issue the warnings, what we have to choose in the warnings, wind speed, hail size, damage, like is it catastrophic, things like that. So we use all of your guys' information to make these decisions that impact lots of lives. So please do not exaggerate, because we trust you guys to give us the correct information, or the best that you can. So it's very, very important to be honest about the stuff you see. And how confident are you that you saw a wall or funnel cloud or tornado cloud? I mean, it's okay to not know. You just tell us, like, I'm not really sure what it is, or I can take a picture and send it to you. Great, that's awesome. We'll take that. So don't worry if you don't exactly know what it is, but just be honest about what you saw. So because we use all your guys' reports and we take them very seriously. And also the location should be address, lat long, or an intersection, and it can be estimated miles from a city as well. So we'll get reports, and they'll be great, like great pictures, great reports, but the person didn't put where it was at or what time or anything, so we can't really use it if we have no context to it. So that's just something to remember, is that if you send us in a report, where, when, how, just remember all that stuff. So, and then follow up if necessary. So if you're getting that first round of storms, you're like, oh, I got pea-sized hail. Second round comes in and you're like, I got golf ball size hail. Let us know. So just let us know what you're seeing on the ground, because we are here in the office and we are issuing warnings for you all, but we are not out there. We can't see what's going on. So we appreciate anything you guys can send into us to give us context as to what is going on. So sending storm reports. You can tag us on social media or call us. Social media, again, Facebook, X/Twitter has been great. Really great, or our contact.sgf@noaa.gov email. A lot of people have sent in stuff from there as well, so we also appreciate that. Or you can always call us. We're here 24/7, 365. Somebody's always here. You can also go to the inws.insep.noaa.gov/report, or you can go to the MPing app. And this next slide just goes through the MPing app really quickly. You select your report type, and you can put hail, wind damage, tornado, and you put your current location, and then you submit the report, and then it tells you successfully submitted. So thank you, your report has been submitted. So a lot of people use the MPing app, and it's pretty easy to use. Heard good things about it. So definitely could be something easy to use and look into. Okay, I think this is the last poll. So let's send out, what is the most important thing to keep in mind when storm spotting in the field? Is it safety, getting the report, or is it the best picture? And I'll just give you guys like 30 or 45 seconds to respond. Um, so far, so good. um, so yeah, it looks like most of you guys have all agreed on the same answer, which means that I did most of my job well today. So I'll go ahead and close it. Okay. Safety, A, you guys are right. Like I said, we appreciate the reports, we appreciate the pictures, but we want to make sure you guys are safe. So that's our main goal, as you guys saw on the mission and everything I went over in the the second or third slide. Our mission is to keep you guys safe. So we love having these talks with you guys, and we're willing to teach you all a little bit of meteorology this evening, but we also want to make sure you guys are safe in doing this all without putting your lives at risk or anything like that. So safety is number one. So as we go into safety, let's just quickly go over some severe weather safety and preparedness, especially as we're in spring and we've already seen a couple of bigger storms this season. Our website is weather.gov/Springfield, and you can get our forecast there. And then on the right is just some graphics we'll post on social media. As you guys know, we're on Twitter and Facebook. And so that's what a few of our graphics will look like on the right side. We'll do like excessive rain or severe thunderstorms possible. So it's just a couple of examples there. We also have what's called our experimental graphical hazardous weather outlook. We just call it the GHWO. A lot of acronyms here, but what it is, it has like these little chiclets, and it will go through the next like 3 or 5, 6 days out, 6 to 7 days out. And what you can do is you can go through the hazard risks, and then you can hover on the chiclet, and it'll tell you. So those colors. Like as you can see on this one, the severe thunderstorm risk for Sunday night. This is really, really old. This is not current. This is from like 2 years ago. The threat risk is yellow. It's limited, so that would correspond with the yellow chiclet. So you'll have a legend on the left side of whatever hazard you go through that tells you what those colors mean. So that's a pretty cool place to look. And like I said, it's on our website, weather.gov/Springfield/GHWO. So you can always check that, and it updates when we update our forecast. We definitely update our forecast at least twice a day, but it's usually more than that, especially for like the short term, like today and tomorrow. So you can always look at that if you're curious about it. Have multiple ways to get warnings this spring. Like I said, as you all probably know, we've already seen storms this year, especially overnight evening storms, and we have a potential for severe weather coming up this next week as well. So we just want to make sure you have multiple ways to get warnings, whether that's watching TV, internet, your phones, weather radios, outdoor sirens, or your family members and friends and coworkers. So get involved, advocate, including people with disabilities and others with access and functional needs, into emergency planning in your community. Just make sure everybody has a plan, everybody knows where to go. And there's 12 ways to prepare. It's just making sure you have a severe weather safety preparedness kit. Like it could have flashlight, batteries, bottled water, chargers, things like that. So make sure to turn on your wireless emergency alert and on your phones, because some people turn them off, but make sure you have them on, especially through the springtime. But yeah, I mean, this is just really easy stuff. You can just have in a to-go bag and have ready to go. The spring tornado sheltering guidelines, it just kind of tells you what are the worst options and the best options. So worst options: mobile homes, vehicles underneath the highway overpass. That is a no-no. I know people do it, don't do it. Best options are above or below ground tornado shelter and specifically designed FEMA safe room. We understand not everybody has access to that, but if you're curious, you should check out in your communities to see if you do, because some do, and that may be at your local schools or high schools or things like that. So it's always good to inquire about it if you're curious. But another good option, if you don't have that or don't even have time to get there, is an interior room of a well-constructed home or building or a basement. So, but one thing to note about the schools in those shelters, the gyms are not good. So they may have separate shelters, but gyms in a school are usually not very safe. But so just have a plan, be aware, know where you would go if this happened, whether you're at work or at home. And also it's good to tell if you have kids or older family members living with you to make sure they're aware of what they need to do and things like that. So again, just warnings, confirmation means you need a shelter. So we got a warning now, and then we say, hey, we've got confirmation from law enforcement that the tornado's on the ground. You need to start sheltering. Just the last couple slides to finish up this talk. We're always looking for Weather Ready Nation ambassadors, and this is mostly for organizations that can apply, and it's basically just resilience against extreme weather events and what you can do to inform and empower your communities and businesses to be ready. If you're interested at all in that, you can always give us a call or contact us at our email. But even if you're not a Weather Ready Nation ambassador, you can do your part in, like I mentioned in the slides before, of getting the people that you have around you prepared in case severe weather does occur is just as important as a Weather Ready Nation ambassador, because you are kind of like the ambassador of your home or your business. So, I mean, you can do it at the smallest level as well. So this recording will be available on YouTube, and our YouTube channel is youtube.com/NWS Springfield. And you can always, for more information, go to weather.gov/SGF/Skywarn-Spotter. And I want to thank you guys for attending. Hopefully that was all informative. Hopefully I did a good job and you guys learned at least one thing today. But I really appreciate you guys taking time out of your evening to come listen. And we love doing these things for you guys. And then hopefully our other meteorologist, Peyton, she was the one answering your questions in the message center. So hopefully she was able to answer all that for you, and thank her for her help. But yeah, we really appreciate you guys coming. And if you guys have any other questions, you have all of our contact information on the right side. And like I said, this recording will be available later. But I made it under an hour. It's 7:59 here. So with that, I'll let you all go. And we really appreciate having you all. And remember just to stay safe this spring.